Good morning, let's have a class. And your grade should be put onto eCampus sometime today or tomorrow or sometime this week. Okay, so we will move on to is exam 4, which is final exam. Exam 4 is not accumulated, so final exam is just the last section. So this section we will talk about is we call applied microbiology. Couple topics we will be covered. Applied microbiology. So what we're going to have a couple of sections. First of all, we would love to talk about food safety. It is food microbial safety, which is my research area. So we will talk about that today. And it's corresponding to your lab work, which is analyze bacteria in the different food products. And the first lab is already did, and it's a lot of fun there. Okay. The second one we will talk about is the poultry processing related to microbiology, because in West Virginia area we have a lot of the small poultry farms. We will talk about this on Thursday. Then we will talk about immunology a little bit. Using one lecture, talk about immunology. That will be next week, Tuesday. Next week, Thursday, sorry, not next week. So week coming after the Thanksgiving holiday, and the immunology will be taught on Tuesday, and Thursday we do not have a class. Then last section we will talk about virus, plus the final review. So this will be the overview of these final sections. It is still a lot of material we're going to cover, but most likely it's applied section. So it is different from what we talked about before. It's more scientific section. This is more applied section. Lots of them actually are common sense, but we need to emphasize in these classes, let you understanding the microbiology used in our real world. So first question. Foodborne illness in the United States. This is based on a survey. What is a CDC survey? Centers for Disease Control and Prevention. That is CDC. We have basically a two survey. The top one is very old. That comes from 1999. The bottom one is 11 years later, we did another survey. We haven't done anything yet. How many illness per year in the United States? 75 million. 25 years ago. 20 years ago, it decreased to 48 million. It is still a lot. How many of them are hospitalizations? 323,000. 2,000, 128,000, 2011. How many deaths? 25 years ago is 5,200, right now 3,000. But you can see clearly, although our foodborne illness is decreased because we do lots of the intervention, we establish lots of the federal regulations, our cost is increased almost tenfold. 8.4 billion in 1999, 2011, 77.7 billion, because our medical cost is increased dramatically in the recent years. So that's the reason. This is overview of foodborne illness in the United States. What's the pathogen we care about? These are the things we're going to mention about. Is first of all, Listeria monocytogenes. This is we're going to talk about this real quick. Second one, E. coli. 0157H7. Next one, Salmonella, non-typhi species. We have to say it's a non-typhi species. Campylobacter. This is especially for the poultry meat products. And Clostridium botulism. Clostridium, we didn't talk about too much yet, but Clostridium is another big topic, especially it is an indoor sport pathogen. Okay? These are the pathogens we really concern. Now, of course, norovirus we also care about. A couple of years ago, about like 10 years ago, there were big outbreaks in Yellowstone National Park. Lots of people get diarrhea, vomiting in like couple of hours. Shigella, we talk about the Shigella toxin, same as E. coli 157H7, but it's made most likely for the daycare kids. Toxoplasma, it's for pregnant women because that's a parasite which is on cats. Last one, since we just have a COVID-19, so always remember there are the emergent organisms, always gonna come. And then they say that 10 to 15 years, they will have a new microorganism comes. So for example, we talk about the Clostridium difficile, CADIF, remember? We talk about CADIF. This is the one we actually think about. It's an emerging organism for food safety. Because originally it is only for hospitalized patients. Remember, it's using antibiotics to dramatically, in like 7 days, had blood water diarrhea and with pseudomembrane titers, but it's also engaged and invaded into the food supply chain. So those kind of examples, we call it emerging organisms. So we have a couple of the survey to show you. The table number two. Top 5 pathogens caused domestically acquired foodborne illness. What are they? Number 1 is norovirus. Number 2 is salmonella, then followed by Clostridium perfringens, cause gas gangrene, remember? Campylobacter and the Staphylococcus aureus. So we talk about chicken salads, that is the Staphylococcus aureus. Very interesting, Staphylococcus aureus, honestly, is not required to report to CDC, but the others are required to do that. So this is top 5 pathogens cause foodborne illnesses. One of the top 5 cause hospitalization, which means they have to go to hospital. Number 1 is salmonella. Number 2, norovirus, followed by Campylobacter, Toxoplasma gondii, and the last one, Shigella toxin generated E. coli. This STEC is Shigella toxin generated E. coli. Shigella toxin generate E. coli. That's called the STEC acronym. Okay. This is the one is important. That's top 5 pathogen cause deaths in the United States, because that's what we really care about is the deaths. Please just keep quiet a little bit there, please. The number 1 is salmonella, then Toxoplasma gondii, followed by that, then Listeria monocytogenes, norovirus, and the last one is Campylobacter. So, all these pathogens, actually, which one will cause the most dangerous and death rate in the United States is salmonella. That's why your chicken products, I say you can take it to the home, but you have to be well cooked. Because salmonella is the number 1 pathogen cause death based on the survey from the United States. And it is very surprisingly, it is not 0.157H7 because we had a zero tolerance policy for 0.157H7 in the ground beef. And we will mention really quick. This is the foodborne pathogen concern for different products. So fresh meat, we care about salmonella, Campylobacter, E. coli 0.157H7, and the non-0.157 Shigella toxin E. coli. We'll mention this real quick. Ready-to-eat meat, which means hot dogs, daily meats, turkey breast, frankfurters, summer sausage even. Those we care about the Listeria monocytogenes. Now fresh fruits, produce, salmonella, norovirus, E. coli 0.157H7. And this is the one is important because you usually heard about the news. If you look at the CNN, Fox News, usually they will tell you there's outbreaks of hot dogs related to Listeria monocytogenes in some plants, because all those pathogen is targeted for those for the food vehicles and will cause the problem. And this is based on is almost like recent 30 years the outbreaks happen in the United States. That's why this slide is important. It tells you what are the important pathogen target of this food. So let's talk about Listeria monocytogenes first. This is basically a 6 species for Listeria. And we talk about the Listeria monocytogenes, and we have a surrogate. A surrogate, which is Listeria inokia. That is a surrogate. Lots of the time, we're using Listeria monocytogenes to do antimicrobial validation study, but in certain scenarios, we cannot use foodborne pathogen. We have to using a surrogate. Listeria inokia is a good surrogate. Now, you have other species, Listeria cereularium, Ivanovi, Wishameri, and Greeny. Those basically is a pathogen from the soil and not related to the foodborne pathogen. So we have those stars there, which tells you monocytogenes inokia basically is a topic here. What is Listeria? What's the characteristics for that? This is gram-positive, large shape, a very large lot. It has a very strong moving capability because the flagella is Petrotrichus. Remember Petrotrichus? Flagella is covering the whole surface. The bacteria we talk in the lab all the time is Proteus vulgaris, but I tell you one thing, Listeria monocytogenes is a Petrotrichus, which means it has a very strong moving capability. Now obviously it's a facultative anaerobes. This is not surprised. Most of the bacteria are facultative. Remember, they can grow with, without oxygen, but grow better with oxygen. And this is especially important for the food products because the food we can do vacuum package, we can do aerobic packaging, we can do modified atmosphere packaging. If the bacteria, the pathogen is a facultative, gives them a very available, we say it's a friendly environment for them to grow. Last one, this is the hemolysin. Remember blood agar, the hemolysin, beta hemolytic, alpha hemolytic? It's a hemolysin because of the sterolysin for the lysis blood cell. In the United States, we basically have 13 serotypes. But 95% of the foodborne listeriosis is caused by those two strains, which is 0.5A, B, and 4B, especially the serotype is 4B. The serotype 4B responsible for 65 to 85% of the whole foodborne illness in the United States. That's a target. What we should be care about it. Bless you. At the back, can you guys please don't chat there, and because I hear the voice all the time. Listeria monocytogenes grow. Their characteristics you listed here, but we can do some of the conclusion. Why this guy is a risk in the food processing environments? Number one, this is resistant to 10% salt. And remember, salt is a natural antimicrobial. It has been there for many, many years, maybe 1,000 years. Since you have a food product, you have a salt. From the food quality standpoint, this is the one to gluten protein, which is called the natron. Also, from the flavor standpoint, it gives you some of the flavor. But from antimicrobial standpoint, this is a natural antimicrobial for the salt. Because it will cause osmotic imbalance of the bacteria. However, Listeria monocytogenes can grow up to even more than 10%. What this means? This is the hydrophile. This is the reason why hot dog, frankfurters, daily meats, even we think it is a high salt unhealthy products. But the Listeria monocytogenes you can grow because it's resistant to 10% salt. You eat hot dogs, you know it's very salty, very salty. You can't just keep eating like 10 hot dogs. You're gonna have to drink a lot of water. So high salt products. Okay, halophils. Another halophil, remember we studied it before, is Staphylococcus aureus, because it can be widely existing on skin surfaces. So that's the first thing. Second, when you look at here, they can grow a minimum range of 0.5 to 3.0 degrees Celsius. What this means? They can grow well at refrigerated temperature. So what's the terminology for that? Psychrophiles, that's all. That's really risky. All the time what we do vacuum package, then we put them in the refrigerator. Because it's a very low temperature, it's only 3, 4, 5 degrees Celsius. So we think it's safe, bacteria will not grow. But unfortunately, Listeria monocytogenes is going to grow there. And it grows very well, I can tell you. That's another risk for those food products. Then you see it again. Secondary only to Staphylococcus aureus, can grow at the lowest water activity at 0.9 to 0.92. What is the water activity for that one? Water activity, 0.9 to 0.92. This is a salami, summer sausage. Those are or beef jerky even, those are dry products. Lots of the bacteria will not grow even. However, Listeria monocytogenes will be grown. They can survive in the very low water activity, which means available water for them to grow is actually very, very low. Last one, look at the pH. They can grow pH as low as 4.1. That means it is kind of an acidophile. This means when we talk about, in the last lecture of exam 1, we talk about these external factors to affecting bacterial growth. Listeria monocytogenes can survive all of that. That's why it is very difficult to control. This gives you trouble. This is back almost 24 years ago. In 1998 to 2002, there is a multi-states ready-to-eat meat outbreaks related to Listeria monocytogenes. This cost the economic losses almost like $500 million, could go billion. How many cases you add up them together? Almost close to 200. How many deaths? 35 deaths. Remember, Listeria monocytogenes is also going to cause miscarriage in stillbirth and could cause meningitis. How many states is involved? 42 states in the just couple of years. So we have to control it. What we have to do? We did a survey first. This is a survey. Listeria monocytogenes annually in the United States, 1,600 illnesses. 1,500 hospitalization, 260 deaths. Therefore, there is a recommendation for you. If you're a pregnant woman, you shouldn't eat like daily meats naturally. At least you do like some of the heat treatment like microwave. Because death rates is very high. And other people will be a target is immune compromised patients. And which means the immune system is not developed very well for some of the reason. And also kids, older people will be a target. So in order to prevent, or we say proactively control this pathogen, USDA FSIS has 3 alternatives. They actually, we will say, cooperated with FDA. They have three alternatives. Number one is post-lacerity treatments with antimicrobials. What is post-lacerity treatment? Well cooking. That's a post-lacerity treatment. Or you could do like radiation or some kind of things. You have to do antimicrobials with. What is antimicrobials? I don't know you even noticed it. If you look at the bag of a hot dog, just from Kroger, you will basically see potassium lactate. That is a basic antimicrobial. And you will also see sodium diacetate. Those are the most common antimicrobials. However, they are not going to curing them. They only do is inhibit. So we have a terminology we call it static. That's antimicrobials we use a lot. Of course, lactic acid, citric acid, all those we could use. But potassium lactate and sodium diacetate is most widely used. Second, we could also do post-lacerity treatments or antimicrobials. So they give you some of the flexible to do it. Said, okay, I just want to do one of them. Then the USD FSI said, yes, it's okay, you can do it. However, if you said, I don't want to do anything, I don't want to do post-lacerity treatments very well, I don't want to do other antimicrobials, I want to do organic processing, then you have to do a very good sanitation. And frequent microbial sampling. And I want to tell you, this is a topic we could talk about the whole class, microbial sampling. It is very tricky and difficult to do because of food products is a matrix. The geometry is not uniform a lot of the time. So you cannot testing everywhere. And sometimes you had 1,000 hot dogs there. How many you should sample? There is no way you sample all of them. So there is a statistics analysis behind it. How many positive, how many negative, you should reject, you should accept it. It is complicated. I just want to tell you, it's not that easy. Microbial testing and sampling is always a tricky issue to talk about that. Okay? So, but that's the three alternatives the USD FSIS pointed out. However, you see right now even, you look at the news, the outbreaks related to Listeria monocytogenes is all the time. And not only for that, it has been invaded even into like a fresh produce or other places. So if you look at the USDA website, Listeria monocytogenes in fresh produce, they actually give you a category is emerging organism. They think it's in a ready-to-eat meat, it is a top risk. In fresh produce, it is an emerging organism. Okay, we'll talk about the fresh produce real quick. Pathogenic E. coli. We already talked about this one already. Remember the first day of the class? On the right side, I have been writing on the blackboard. E. coli is a little bit complicated. It is not that simple. Although that is the only bacteria name you will be remember the rest of your life, even you forget most of the other pathogen names. So what's E. coli? It's Escherichia coli. The Escherichia coli, large shape, single rods, gram-negative, we did a lot. Lactose fermentation positive, we can talk all the time. There are 4 different categories for the pathogen, EHEC. Enterohemorrhagic E. coli. This is the key. We want to talk about that. Other than that, we have enterotoxigenic E. coli. We have enteroinvasive E. coli. pathogenic E. coli. And don't forget, we have a generic E. coli. Remember the generic E. coli, we have to be zero tolerance in the municipal drinking water because that tells you it's a fecal contamination. And do not forget, urological E. coli. This is another emerging pathogen. Urological E. coli, we talk about in the lab, E. coli is a #1 urinary tract infection disease caused pathogen. But if the urine sample goes through the supply chain, it could cause a problem. And do not forget about the other E. coli. We had an E. coli. 9037, that's a good one. That is for fermentation. It's a beneficial bacteria. Okay? So there's a lots of different E. coli we want to talk about. But here we want to talk about this stuff. Enterohemorrhagic E. coli. E. coli 0157H7 belonging to that because it will cause HUS, hemorrhagic uremic syndrome. Water diarrhea with water diarrhea with blood sample in the kidney area and also the damage. It could be also invading your urological system, neurological system. Like I said, immune-compromised patients, older people, and kids are the risk. The severity rate is very high, 5%. This is the one. At the beginning, it comes out in 1982 in Oregon and Michigan, in Grand Beach, place. Nobody really cares about at the beginning because you have some diarrhea, water diarrhea. Just rest a couple of days, it's good. People find that why it will cause HUS? Because of Shigella toxin. And Shigella toxin, we have Shigella toxin 1 and Shigella toxin 2. We really feel the risk is Shigella toxin 2. Because these two pathogens is an AB toxin. Remember, toxin domain, transmembrane domain, and they will be going to a GB3 place at a kidney, then cause HUS. So, because the toxin is Shigella toxin, so what we can do? We can do a rapid testing. Lots of the companies, they are developing a rapid testing for E. coli L157H7, is doing the enrichment using the polymerase chain reaction, which is PCR,